Just kidding. It was a lot of fun Friday though, Tim.
Oh, I loved it. Even though
Especially Andre bringing in the two Omicrons in SIG.
that was a real hit.
Yeah. And
That
there's
was,
two Omegas up there, Tim, not too far away. Omega
well,
Cygni.
well, Chuck
There's another pair up there.
Chuck kind of came and told me, Tim, that's called Omicron
Okay, we're live streaming.
Okay.
Cygni. Okay.
Are we ready, gentlemen? Are we on the YouTube?
Yep.
People do that thumbs up like thing with us? We're not a membership thing except for a club. But anyway, welcome aboard, everybody. Here we go again. The SBAU Astro Hour, number 187, stands for Santa Barbara Astronomical Unit. The AU, of course, 93 million miles from the sun, our Mother Earth distance. And we, the board of the club, and some great members on screen, supporters, meet on screen every Monday morning, YouTube, through Zoom. And today we kick around our favorite topics. Our club's based at the Santa Barbara Museum of Natural History, where we hold our monthly meetings. First Friday at Fleischman Auditorium, and then a week later at the Observatory, nighttime for the second Saturday Star Party. Also getting back inside Gladwin Planetarium in early October. It'll be the night of the 4th when the speech will be on dark matter. Get the whole story, everybody, at sbau.org. Ronnie Herron's my name. I'll introduce you to the rest of the gang here in a minute. We're going to talk about these cosmic topics this week. The starbirds of the night sky flying south for the winter. Something called Porphyrion. What the heck is that? We're going to tell you. How about the Cygnus Rift? I had a bad case of it once. We'll visit Triangulum, third largest of the local group. And Apollo moon rocks indicating lunar volcanoes. Whoa, and a Chinese comet having something to do with Australia? We're going to find out about that too. And we're about to get a temporary second moon doing its imitation of, I guess, Oumuamua, except not through the solar system, through our orbit. We'll talk about that. Let's meet everybody. Here's our beloved President, Jerry Wilson. Hello, Jerry.
Good morning.
Lovely Pat Forgy. He's the man in charge. Sends me incredible stuff. I consider this, my name's Ronnie, incidentally. I'm vice president. I consider this like a weekly class session out at Broida Hall in astrophysics. Pat Forgy doing okay?
Yep, she's fine.
And your dog that was bitten by the snake is going to live?
Yep, she's fine too.
Okay. Here is our outreach coordinator. He's one of the best, Chuck McPartland, in charge of all the events, most of the events. He's married to Pat McPartland, who is his wife, merchandise manager, treasurer. We have on board Mr. Tim Crawford, expert lensman.
Of course.
Incredible telescope. You'll see him on, I guess, all kinds of things. Saturday star parties, Tuesday the workshop. That's tomorrow, right? Are you involved in that anymore, Tim?
Yeah, I still go and listen to these guys. They're way over my head, but it's a lot of fun.
And he's married to Karen, and I assume she comes to meetings. I'm not sure I remember your wife, Karen. I don't think I've ever met her. Maybe
I'll drag her in sometime.
drag her by the hair. What a mistake. Us cavemen. And here is our resident punster, Mr. Tom Whittemore. Hello, Tom. Former Westmont professor of science, and he is our editor, and he does the puns. Here's a Whittemore witticism of the week. Do you know the status of that poor little kid that swallowed all the coins, Tom?
No change.
Oh, okay. Okay.
Actually, I got one for you, Ron.
Okay, you got your own? Well, then I'm going to count on you to come up with one every week. Go ahead.
Okay, a tachyon walks into a bar, and the bartender says, "I'm sorry, we don't serve tachyons here." So he left and came in the previous night.
Those tachyons will do that.
Yeah.
And what's the one that has the line, "I'm traveling light," a light wave or so light?
Photon.
A photon.
Back in the day when they thought they discovered that neutrinos traveled faster than the speed of light at Gran Sasso in Italy, the joke came out in physics that a neutrino walked into a bar and said, "Why is it so dark in here?"
Okay, we got stuff like that coming up on screen right now because President Jerry forwards us silly science cartoons all week long, thought provokers. We get at least a half a dozen, and away we go. There's the kid trying to get to the cookies, standing on the metal kitchen
That's cool.
trash thing that has a pedal that opens the lid, and there's a kid that's going to work for SpaceX someday with a mallet.
Yeah,
It's
this is pre-astronaut training.
That's true. That's what it is. 4, 3, 2, 1. Need a follow up on that one. Okay, throw some more. This one, I'm not sure I get it, but the chicken does apparently. When you get it, he's sitting on the pie sign, and it's in its beak is a frond of cannabis leaves. And are we supposed to get what? The imaginary number goes on forever?
Chicken pot pie.
Chicken pot pie. Okay.
Oh God.
That's awful.
I thought that was so easy I wouldn't put it up, but I did.
No, I didn't get it.
I didn't get it.
Last week it
Well,
was
it shows the crowd you run with.
Yeah, you can have a lot of fun with that pie sign. Last week it was a bunch of scientists having a pie fight, throwing
Yeah.
the little pie thing.
Yeah.
All right, here's a better universe than the one we live in because the basketball player pro was standing there while a stretch limo goes by and he complains, yeah, well, there goes another school teacher who makes 10 million bucks a year. Meanwhile, I'm working my butt off playing professional hoops and I can barely pay rent.
Yeah, right.
That's not
Another
our
universe. That is.
The way it should be. My God, that's great. And here is a coming of age story with a young bear trying to buy a 6-pack of beer. And he gives the card to the guy in the liquor store. I am 21 in bear years.
Pretty
It's
good.
a minor.
It's Ursa Minor down there, yeah.
Right. IPA. See
Oh,
that?
I see. I didn't catch that. It's a minor. All right, got it. Bizarro.com. Okay, a man that checks into a hotel room and calls the room service. Hi, I'd like a wake-up call. He gives you one. Okay, sir. The 12 hottest months on Earth in the last 100,000 years all happened in the last 12 months.
I really like that.
That's your wake-up call, America.
Good.
Yeah.
I like that one, Jerry.
Okay, good.
These are thought provokers as well as silly science cartoons. Okay, what are we going to talk about this week? My favorite, my daughter sent me something about that incoming secondary moon and the thing I sent back to her was, how is it going to orbit only once and then take off? How do you do that? And you are going to be talking about that at the end of this hour, Jerry, with a diagram that explains it all. Meanwhile, the night
Can you
sky.
see this?
Uh-huh.
Okay. Let me make it bigger on my end here.
The world with a concave horizon.
Yes.
Nice.
Okay, I overdid it here.
Oh, that
Oops,
That's
now I
good.
only
That's
told you
readable.
guys.
Yeah.
Uh-oh,
Wait a minute, I got all screwed up here.
get lost. Hit it reverse.
even
Yeah.
made Ron go away for a minute.
I made all of you guys go away on mine and I don't know
You
how to
don't
get out
miss
of it.
me, but you need that night sky.
Okay, so here's the, can you see this?
No.
No, okay. Uh-oh.
Uh-oh, I don't like that's like the brain surgeon in the middle of the operation. Uh-oh.
Or oops.
Oops, that's even worse. All right, at least we got you on the screen, Jerry. Last week we couldn't even do that.
Yeah. Huh.
I'm glad this isn't
just
the
need to
Enterprise
share?
movie.
No, I can't even get back into Zoom. I've just got this giant picture stuck on my screen.
You suppose
Okay,
there's
there we
people-
are.
Ah, here we go. Just wonder if it's conspiracy. Every week come up with something new. There we are.
Oh, I'm very creative. Okay, this is a how-to find M11, the flying duck cluster, which is an asterism that I have never seen justification for the flying duck in. I cannot pick out the pattern of a V-shaped set of flying ducks. But anyway, in the evening at 10 p.m., it is right here. You see the cursor?
Yep.
Okay. This is Aquila, the eagle. There's its asterism. It's right down at the end here. And Tim has sent a nice star hop to it.
Before you do that, can you go back to the other one, Jerry? Without, I hope I'm not. Yeah, what I always used to look at Aquila as instead of an eagle is that if you take at the top where Altair is and then the two wing stars, it kind of looks like an umbrella. And down at the bottom, there's like a little curved handle. And at the end of the handle is M11, but it never worked. I searched. I have such a hard time finding this thing. So in the next screen, I sent you that star hop.
Okay. Now this would be an umbrella if it got caught in a windstorm.
Yeah.
Or some people think it looks like a bat ray.
Oh, okay.
Okay.
Not the first thing that comes to mind, but okay.
Is
So
Aquila
this
the
is,
name? Is Aquila the name for eagle in an ancient language?
Latin.
Latin, Latin.
Okay.
Now this is what Tim was just talking about. This is a chart courtesy of Tim. There's Altair, which has always got its two wingmen, and that's its distinguishing feature, how I can identify it. So you go straight, well, not straight down, that would be 90 degrees, but there you go down the handle. M11 is right here.
So it's almost going through that the A star. It's almost going through that center star, and
star.
That's Delta Aquila.
Delta.
Yeah,
Delta Aquila, and then but the other one that really works well,
Delta.
but it has to be a darker star, and then Jerry can tell you these two stars here at the bottom. I think what is that, Lambda?
Yeah, Lambda Aquila.
Aquila,
Right there.
and the other one is Ionina.
Yeah.
And those, if you draw a line in the night sky, if those two things, if you're at a place like Refugio where it's dark and you're looking out over the ocean, those two stars are really noticeable. But just a little bit of city light will just blow those out, and then it's hard to find them. But it's not quite halfway. But it's just short of halfway, and that's a really good way to find that wild duck cluster. It's one
what
of the.
You're saying is between Iota Aquila and Ionina.
No, between Lambda.
Lambda.
Oh, Lambda.
Yeah.
And Ionina. Okay.
And there's two of those stars that are really, I think those are the two that are much brighter in the sky.
Huh.
And if you go kind of just short of halfway with a low power, you'll find it, and then you can pump up the volume a bit. But I found out there at Refugio, I have a 17 millimeter eyepiece that really works well out there over the ocean. When you find that wild duck cluster, it's one of the best views I've ever had of that. And I've never really appreciated it like you, Jerry. I can't see the V. As a matter of fact, we had a customer up there at Westmont one time, and I was explaining the wild duck cluster is a big V of stars. And I said, and I mentioned, you can't really see that. But she didn't hear me say that. And she looked at it and she says, I don't see what you're talking about. And I said, well, it's right there in the center of the eyepiece. And she goes, no, it's not. And we almost got in an argument about it.
You got a fighter there, huh?
Yeah. I said it. She goes, well, you said it's a V. And I said, no, I said it's not. Anyway.
Mr. President, you titled this section the Flying South for the Winter, the Starbirds of the Night Sky. Does that mean we're losing the duck cluster in months to come?
Yes.
And Aquila and Cygnus, the swan?
Yep.
They're all going below the horizon.
These are early evening in the fall, and they'll be gone by winter.
Yep.
Cygnus will be looking like it's standing on its beak on the horizon at midnight on Christmas.
Yes, it looks like a cross, they're checked, yeah.
Huh. I didn't know that.
You can see here the clouds, the star clouds of the Milky Way, and they're going up here. This is more dense down off the bottom of the field of view. That's where the center of our galaxy is. And this is the start of the Great Rift up here, the big dark nebula that obscures most of the Milky Way up here. So these are summer features.
Wow.
They're overhead at midnight in the summer, a few months ago.
Isn't there an owl nebula or star cluster out there?
There is, but that's up near the Big Dipper.
There's
Okay.
both, yeah.
Oh, yeah, that's right. We saw the owl cluster last week, I think.
Mhm.
So,
Yeah, it's coming back.
Mhm.
okay. Now, this is a telescope view of M11 taken by Stefan Rahn. And when you take a picture of something, it shows a lot more stars than you would see with your eye in an eyepiece. So I guess the V, wherever it is buried in here, but it's got too many neighbors. But it looks like a brighter star thing could be this and this, one side and then the other. But these things clutter it up. So
I think the V, Jerry, goes to the upper left. And if you put your cursor on that nose star there,
that
just
one,
little above, right there. Okay.
Okay.
That is the lead duck in the wild duck.
Okay.
That's
And
how.
if
Yeah.
you take those two bright stars kind of at the lower left, just off the main cluster,
Mhm.
then it could be a peking duck.
That's pretty good.
Oh, God.
And some fun
Okay,
now, boys.
we have cards today and they need to be dealt with.
All right.
Okay. This is a amateur shot, or this is a planetarium shot.
Mhm.
It's not an actual photograph, but it shows the region that is M11, and this is the field of view of a 6-inch telescope at 50 power.
Oh,
So it simulates what you would see. And I was digging around that because I was trying to find what it would look like in a telescope, so maybe I could visually. And this is one person's representation of it. So it looks like a cube to me. So maybe a bomber formation to be safer or something.
But it's named the duck because of the
The
V.
wild duck cluster.
Wild ducks.
so a
Because
10 millimeter eyepiece, right?
They didn't give the focal length of the 6-inch.
I have a 600 millimeter f4.
Okay,
So a 10 millimeter eyepiece would
that would do
be
it.
that view.
Yeah. There's a couple of planetarium software that will do this. It'll imitate your field of view.
Yeah, that's nice.
So,
the 11th item that old man Messier discovered.
or listed.
He
Or
listed it.
He
Yeah.
was looking for, what was he looking for? Comets, right?
Yes, he was looking for comets. This was an aid to him finding them or
Got it.
eliminating false contenders, pretentious. This is a map of the sky at 9 p.m., almost directly overhead, where the Milky Way is dominated by Cygnus. And Cygnus has a lot of structure and it has a lot of things. It's got, first of all, you can see all this dark region, the great rift up here. Now, when we were looking at M11, that's off the field of view down here at the bottom at this time. So you can see this is the great rift up here at the giant dark nebula. And in a few places, the dark nebula is illuminated because it's got stars or star clusters near it that shine on it, or that ionize it and cause it to glow. And that would be the North American Nebula and the Pelican Nebula, the most famous ones. But it also has, it doesn't show here, but it has a Veil Nebula structure in it, which is a giant shell of a supernova explosion quite a long time ago, several thousand years.
And that one, to find that one, you go from Deneb through the left star in the wing. Not that one, the one inside that right there. And then you just go out a little bit further and there's a star in there called 52 Cygni.
Yeah.
And it's dead center in the veil.
Yes. A beautiful sight. And in low power eyepieces, like our 6-inch at f50 power, you can frequently get the entire, both sides of the bulb of the circle.
Ooh, didn't know that.
Those three blue dots are probably different, brighter parts of the veil.
Yeah. My NP 127 at low power will, with a 27mm eyepiece, will show the entire structure. So,
But that red line across the middle, that's the wings of the swan, right?
this is the wings of the swan,
Got it. I
the
got it.
neck of the swan.
Oh,
The head
next.
is Albireo. This is the tail. If it
Oh.
were the other way around, if the head were on the short end of the stick, that would have to be a falcon or a eagle or something, because that would be a bird of prey.
And then I think that blue dot below Satyr there, I think that might be the Crescent Nebula.
Hmm.
Van Gogh's ear.
I thought the Crescent Nebula was over near Orion, but maybe not.
Yeah, in Canis Major.
Yeah, a Canis Major.
Well, what am I thinking of?
Or is that the Thor's helmet?
That's Thor's helmet. This one here, I think, is the Crescent, and it's
Okay.
also known as Van Gogh's ear. And the blinking planetary is off that right wing.
Yeah, these are a lot of the structures that you see in, not here in this visual, but what Tim was
Ooh,
talking about is things you see in Cygnus, a lot of structure. This shows the great rift of our galaxy. This is an X-ray picture, very energetic. This is the center of our galaxy here. Big
Got it.
loop of ionized gas going off into intergalactic space. Here's the great rift, and this region up here is the nebulosity around in the Cygnus. The
is that the North American?
Yeah,
Oh, wow.
Is this the only rift? What does rift mean?
pair,
Opening?
missing section.
Oh, okay.
Canyon or opening.
Yeah,
Are there any other rifts up there? Is there only Cygnus?
There are small ones, but that's the major one.
yeah.
Okay, and it happens to be right on the Milky Way's.
Well, that's where the gas and dust is.
Yeah,
Yeah.
it obscures the star clouds and makes it look like there's nothing there, like it's a hole. But it's not.
But Jerry, is that rift? Is it really just thick clouds that the light doesn't get through? Is that what
Yeah.
it is?
Mhm.
Oh, okay.
Molecular complexes.
Oh, okay.
But you said this picture was taken with X-rays, not infrared.
That's correct.
Infrared would give us, you can look through to see the black hole in the middle, can't you, with infrared?
Certain wavelengths, yes.
They get a look at the black hole with radio waves.
Oh, okay, got it.
And infrared for those fast moving stars going around it.
Yeah, really long wave infrared.
Okay.
The what is it, that telescope, the James Webb. This is a close-up of the dark nebula LDN 981 and a star VI331 or V1331, taken by a telescope, probably a 24-inch at Mount Lemmon. This is the star at the end. This is material that is a dark nebula again, spread all over the place.
That's a chicken foot.
Okay. And this is a star that is in that chicken foot, in the toenail, the claw. So it is illuminating the gas, the dark gas that would be dark, except that it's illuminating.
And the foot itself is made of gas and dust?
Yes.
Yes.
Yeah. It would be a nebula if it had light shining on it or a hot star embedded in it. These stars here are in front of it.
Hmm.
So the stuff that's farther away is darker, is gone. And the stars out here that are smaller and fainter and farther away are kind of reddish or orangish because they are reddened by the dust. So there's a lot of dust here, but not enough to obscure the view. And
The dust absorbs and scatters the blue wavelengths, so they look redder.
Yeah. Same reason the sky is blue.
Well, it could also be an arthritic starfish.
A good one, Ron.
Now, this is a picture of the North American nebula here. You can see this is in the future here with global warming. Florida's kind of gone. It's underwater now. Word to the wise, don't buy real estate in Florida. I'll get letters on that. This is the Gulf of Mexico here, down here to the Panama Canal and up the West Coast. So it kind of mimics North America. This over here is the Pelican Nebula. There's the back of its head. There's its beak going down there. So, and its eye. And these are very diffuse objects. They cover a very wide field and they're very faint. This is
Jerry, have you ever imaged this?
No, I've tried it a couple times. I don't get enough density. I don't have dark enough skies when I attempted it to do that.
Oh,
I have some images that I think might contain it, but I haven't really processed those images yet. So, but I took those with a camera mounted on my scope because this is a wide field object. Although a lot of people in our Tuesday workshop have imaged this very well.
yeah, those Cat 51s. Those I can't remember who makes those, but they're only a 50 millimeter telescope, but real wide field. And I think Dick Beam has done some unbelievable work with those.
Wide field like that, you need a dark place, a dark sky, because you're going to pick up a lot of stray light around the object.
Yeah, he does phenomenal stuff.
Okay. The
Veil.
This is the Veil Nebula, the Western Veil, the Eastern Veil. This one is called, this is the Witch's Broom. And the star 51 Cygni is right in here, I think.
Just above it.
It
is right there.
This is a UV picture, deep UV. So it may not be recognizable for a lot of features that you know and visible, but it has a lot of structure by itself. The southeast knot. This one is called, what is that? The Wizard Nebula?
The Waterfall.
Waterfall. Okay. And then this one is someone's triangle.
Pickering.
That's more to the right. It's indicated.
Oh, that's this. You're right. Pickering's triangle. Yeah. I guess I should read my own pictures.
Well, there is a name for those two little circles, and I can't remember what it is.
Oh, it's NGC 6971 and whatever that says.
They give NGC numbers to stars? I thought they were bigger items.
No, these aren't stars.
Oh, I didn't think so.
NGC stands for New General Catalog, and it was started by Herschel or Herschel's sister.
So what are they if they're not stars?
They're nebula clouds. And they're the brighter part of it too. And here you see IC 1340. These are also nebula, but they're dimmer. Herschel couldn't see them. But we pick up a lot of things now with big telescopes. And rather than add them to the NGC catalog, for some reason they make an IC catalog. And I forget what IC stands for.
Index catalog.
Index catalog.
Thanks.
Yeah, Herschel started his catalog, but didn't really give it a name. But then his son expanded on it. And then eventually, I think it was Draper at Harvard Smithsonian that collated all those together and decided to make one big catalog and called it the New General Catalog.
Okay.
Jerry, the 6995 and 6992 in the Eastern Veil, are those just areas within that waterfall?
They're brighter regions.
Okay.
Because you can see this faintly in visually, and these are the first things you pick up, and first things you pick up photographically. So
and you can see where there's bright white regions, that's where it tends to have an NGC number.
Okay. This is neat. I wrote all this down because I've always, whenever I look at a star chart, I get the Eastern, Western, and the 69, 60. I get those all screwed up.
Yeah.
But I like this.
This structure in here is fainter, and you probably only get that photographically.
Yeah.
So if our sun and planets, our solar system were in the middle of all that, we'd see none of it around us?
Well, it's
Most likely.
good that you would ask. Here we are, not at the center of the galaxy.
Great.
We're at the center of this circle. And this is the sun's orbit around the center of the galaxy. Here's the center of the galaxy, the galactic bar, because we are a barred spiral.
Oh, wow.
It goes along here. And the Orion and Cygnus branch of the Milky Way is this cloudy thing here, and it comes closest to us right in here, and this is where we see Cygnus looking out this way. Well, no, we have to be looking this way, because down below Cygnus, we see that that's where the center of the galaxy is. This is down in Sagittarius for us.
Yeah.
So,
and we're that little sort of not very distinct bit between the Perseus arm and that Scutum Centaurus arm. So that's the yellow Orion Cygnus thing. It's really not very strong.
no, it's like a little one of these, but it's fainter.
Yeah.
The word
call it-
up.
But they call it a spur?
Yeah.
Wow. And we know there's a bar out there though in the middle.
Mhm.
It looks like there's actually two bars too. That's what's interesting.
Yeah, galactic bar and long bar.
Are they crisscrossed like an X?
Just no, you can see there, they're not at much of an angle.
Yeah. They mostly line up.
So we're in the Orion Cygnus arm. I didn't
Orion
know-
Cygnus spur, it's often called.
Spur.
Yeah.
Okay.
We're just inside of it.
You got people that are going to argue about what's an arm and what isn't.
Yeah.
It's like dwarf planets.
Go.
So when I was much younger and reading a lot of science fiction, they always had this mythical place where strange planets were, and it was called the rim world, or the rim of the galaxy, meaning strange worlds that were right out on the rim. And when I was learning this, I thought, oh, the sun, we're out on there, we're a rim world. But it turns out we're not. From the rim to the center, we're about halfway.
And you can see the ones that have full numbers, 1 Perseus, 2 Scutum Centaurus. Those are the two main arms. And then there's a 1A outer and a 1A new outer. So those are like a spur there, but some people argue that's an arm. And 1A, it's called Norma when it's on the other side down here. And then you've got this 2A, Carina Sagittarius.
And
Those are spurs, the ones with the A's and B's.
Here's 2 Scutum Sagittarius, 2A Carina Sagittarius, 2B, or not 2B, Orion Cygnus, 1A outer, things that Chuck was just rattling off there.
did you say the time to go around, how many thousands of years, or did I miss that?
It's like 220 million years.
Yeah, that's the number I remember. I think the claim has been that the sun in its lifetime has gone around 17 times.
And that's in the millions of years.
Yes.
Yes.
It would be even longer if we were further out, right? And shorter if we were further in.
Well, that's the dark matter mystery. The stuff going farther out, if you accept Newtonian dynamics and no dark matter, then the farther out you go, the slower you're going. But once you get to a certain place around this far out, then everything's moving at the same speed. And that's the mystery, why it doesn't slow down. So they're prophesying all sorts of things. The race between the modified Newtonian dynamics and dark matter, the dark matter is pulling into the lead.
We're going to hear all about it on the night of October 4th.
Oh, we'll hear about that.
Yeah, that's our guest speaker, young.
Yeah.
All right.
Okay. The next topic is the third brightest galaxy or nearest galaxy with us. It is the third brightest. The first being the Milky Way, the second being Andromeda, M31 here, and then M33 here. the Triangulum Nebula. It's just inside the triangle. If you can see this border here, the constellation. These are, what do they call that when they politically arrange the borders? Gerrymandering. It's gerrymandering to keep it inside Triangulum here. So my star hop for this is to start at Polaris and go right through Cassiopeia on this leg of the lower. There's 1, 2, 3, 4. So, and those are the parts of the W, right through the middle part there. And that gets you right to Merak. And then you go equally on either part of it. And you can see M31 and M33. There are shorter ways to get there, but when I have to use mostly very bright stars because we don't have really good skies here. Tim, do you have a better one?
Yeah, Jerry, what I use is there's Shiat in the Great Square of Pegasus. There's Shiat above Alpheratz. Alpheratz is at the top there. So it's kind of the lower left corner of the Great Square. And you count 3 from there. You just on that arc. You go 1, 2, 3, and you reach Merak.
Yeah.
And from Merak, you go 1, 2, 3, kind of up. And 1, 2, 3. And then just to the upper right of that is M31.
Yeah.
Then from that point, if you go to M31, just go straight through Merak, equidistant, you're going to get M33.
Yeah. Okay.
And it's a really, really good hop. I tell people about it all the time.
Yeah, it's not shown complete here, but the Great Square of Pegasus is one of the anchor points of the sky for me too.
Yeah, the arc is, if you see the Great Square and then you see these stars trailing down that left side, it's kind of an arc of stars. And I just use that, 3-star hop, 1, 2, 3, then 1, 2, 3. You get right there.
Oh, I didn't realize they had a hotel down here.
It's TAN though, not TON. Sheraton.
Tom Whittemore, you got anything to add?
No.
Well,
So that's part of the sky.
my question, we're talking about the local group, and this is the 3rd largest, right? We're the
Yeah.
2nd.
Well,
Andromeda
it's the 3rd brightest for us. It may
Right.
not be the largest in the local group.
Oh, I thought it was the largest, brightest means the same thing, wouldn't it?
Yeah, you're right.
Well,
Okay. And there's a couple dozen of these suckers out there. There's the Magellanics.
Those are dwarf galaxies.
Yeah. Okay. And you suppose there's some on the other side of the Milky Way that we can't see because they're right between us and that bulge, or the bulge is between?
there's all kinds of stuff there. Yeah, it's
Haven't
called the
found
zone of avoidance.
them. Okay.
That's because people didn't know these were galaxies. They just thought they were nebulae, and they were wondering why there was this zone of avoidance along the Milky Way.
I'm going to add something weird here, but Tom, you'll remember this, is that when you go to Merak and you go up to Andromeda or down to M33, there's a similar thing in the Big Dipper at that last star in the handle. If you go to M51 and then you go to that last star in the handle equidistance up, I think you reach M101.
Well, M101 is more a triangle with the last 2 stars.
Is it?
Yeah.
Okay.
Tough to discuss that without graphics.
Yeah.
Don't worry.
But
Don't worry.
this is a picture. This is the most detailed wide angle shot of M33. It's taken with the very large telescope, survey telescope, at European Space Observatory's Paranel Observatory in Chile. And you can see you can see the spiral structure very easily.
Yeah.
This does not appear to be a barred spiral. It's a simple spiral. And these red things here are hydrogen clouds where stars are being born, similar to the Orion Nebula or the Rosette Nebula. And they have their own, many of them, and these are visible on a dike site with a big amateur telescope. You can see these, and they have their own NGC numbers in many cases. This is a picture of taken by Hubble, and it is 54 individual Hubble shots all stitched together, mostly of the core region at the wavelengths. Now, Hubble is a scientific instrument. Well, they all are, but it was not designed to take beautiful pictures as its end object. So the wavelengths there do not correspond to what amateurs work with, such as red, blue, and green, trying to mimic the human eye. So things like this cluster up here, this was a red hydrogen alpha region that shows up blue. But in these astronomical pictures, everything you see is false color. It's all added because the bands are different than the human eye is. So, and these are other red hydrogen clouds coming down here. But this is a composition. It shows individual stars in the galaxy, and it shows dark and obscuring dark clouds that are not illuminated except where they block background light. Very impressive Hubble picture.
And did I miss the part where why it's called triangulum? You and Tim were talking about.
It's in the constellation Triangulum.
Oh, there is a constellation called. And what would its caricature be? A large triangle?
Exactly, a small triangle.
Yeah.
A small triangle. Okay. So it's not a triangle with us and Andromeda being
Right
the other
here,
two.
there's the asterism for triangulum.
Mhm.
And these are the borders
Mm.
of the neighborhood.
Mhm.
Got it.
M33 is just in here. Otherwise, if it were right there, it would be M33 in Pisces.
And that's a really weird extension of Pisces over there.
But all
Well,
constellations
they were very well represented at the IAU.
Yeah.
are all constellations made up just of stars, or could any point
Yes.
in a constellation also be a
It's
distant galaxy? Or
just a region of the sky.
It's a region of the sky, and then the stick figures are all with stars.
Yeah.
okay, got it. Fascinating. Far out.
This is a Hubble view.
Hmm.
You can see it's another composite. Hubble is not a wide angle camera. So you can see several frames they figured weren't worth putting together because it didn't add anything to the nebula. But this is a star forming region.
And that was visible in both the previous pictures as bright areas.
Right. So this is NGC 604 in M33. And it's a region similar to the Rosette Nebula. It's a gaseous nebula, and stars have formed in the middle of it. And they're in the starting stages of their solar winds blowing the dust away. So now you're starting to see these stars that it birthed in the middle. And eventually all this dust will be blown out, and you'll just see the star cluster. And then the star cluster will slowly disperse, and then you won't see anything reminiscent of this.
This is the nebula inside M33, the Triangulum galaxy.
Yes.
Wow, we can see
This
that.
is it right here.
That's
Oh,
detailed. Okay. And
In
Hubble,
telescopes that weren't good enough or skies that weren't dark enough to see the whole galaxy, they cataloged that as a separate object.
Yeah. They didn't see the connection.
oh, wow.
And
Now,
that's
this
like
is-
a gigantic Orion Nebula.
but these close-up pictures are from Hubble. Imagine what the Webb could do.
Well, that's what oh yeah, the Webb. I don't think we have an M33 from the Webb. This is the Petey galaxy here, or structure. You know, remember the our gang comedy? They had Petey, which was the dog with the circle around its eye.
Oh,
So anyway, this is like the circle we have around part of Orion, which is called,
Barnard's Loop.
that's it, Barnard's Loop. Yeah. So this is a loop of gas blown out. So a lot of structures similar to what we find in the Milky Way.
Including a bar? Is there a bar in the middle of that?
No,
big-
there doesn't appear to be a bar. There could be a very faint one here. But
Wow.
M33, to my knowledge, is not known as a barred spiral.
But would it be fair to say that within the bar of a galaxy, a barred galaxy, in that bar there are more stars than around the bar or outside of it? Is that a fair
No,
statement?
probably not.
Really? How do we see it as a bar then?
It's a concentration of stars, but you got a whole lot out in the disk.
Yeah.
They're just more spread out.
Yeah, within the bar, Ron, is a pool table.
and a tachyon plane.
Yeah.
Sure.
Okay. I love it. Whee! Amazing that that's in his. Here we go. What is this?
This
Ah.
is the projected, and this might not occur because there is lateral motion that usually isn't taken into account when they figure these things out. But a detailed study shows that they might actually miss each other and just distort each other. But this is assuming a direct collision in 4 billion years between the Milky Way, with the sun looking like a rim star here, and the Andromeda Galaxy. Now, Triangulum is gravitationally influenced by these two galaxies, and it is traveling this way, and the mass of these two are projected to pull it down here, and we'll miss the collision if it occurs. But anyway, we have a 3-body problem. So get your paper and pencil out, reserve a room, a table in the cafeteria, and go to work.
Hmm.
Now this is a giant plasma jet. They found some really large ones. This is an actual photograph of the plasma jet. There's the jet. There's the jet end. There's the jet going out here and jet end. And that is 23 million light years long.
Wow.
So our galaxy is about 1 million light years across. It's smaller than that, but
maybe
it's
half
1 million.
that. Yeah.
Yeah. So 50 million years, so light years. So it is 50 times the size of our galaxy, this jet. From this host galaxy here, so there's a supermassive black hole. This is about half the age of the current universe. So this was about 7 billion years ago that this is going on. So this jet, it's really spinning, and it threw this jet out here. There wasn't much interstellar debris, but here the jet ran into existing clouds and didn't go out as far, and it's very bright here because of all the energy release, because of the collision with the surrounding medium. They've now found 11,000 of these types of long jets, and they're starting to look at this. This one is called Porphyrion, something named after the king of the giants in Greek mythology.
Wow.
So they're starting to look at that in terms of how they affect the cosmos, the cosmic structure, the web, the cosmic web, because our universe looks like a giant spider web with galaxies and galaxy clusters at the knots.
But this all came out of a black hole.
Yep.
Yeah,
Going how fast?
about half the speed of light, I think.
Half the speed of. That's why it stays straight and doesn't, over that many millions of years, you'd think it would bend around and become orbiting or interacting with other bodies that it's passing.
Some of them do. Some of the jets that come out of spinning black holes, the spinning black hole gets perturbed partway through its emission of the jet, and then you can see that the jet takes a new direction. And so there's a symmetric break in the jet going out.
Or you get a spiral looking jet.
Yes.
But this isn't a form. This isn't a form of that Hawking radiation, is it?
No.
Something.
That's a very subtle effect, though persistent. This is a very dramatic effect.
Oh, I see. Got it.
This is stuff that didn't get into the black hole, but got thrown out violently because
from the accretion
the pipe was full.
Got it. And there's not a mirror image on the other side of the black hole going the other way?
There is.
Yeah, there is.
Oh, there is.
Here's the black hole right there. This is the jet going out that way, and this is the jet going this way.
I see. I thought the black hole was off screen at the top.
No, it's in here. It's in the middle of this galaxy right there.
Got it. I'll be damned. And that's a rare thing, or is that everywhere?
Well, I don't know. It depends on how you define rare. There are 11,000 of these they've spotted. This is the
Yeah, not
longest,
very-
I believe.
Okay. But the black holes are supermassive centers of galaxies, right?
Yeah.
I don't suppose there's any rogue black holes out there wandering around the universe without a galaxy around them?
Sure.
Oh, yes.
Lots
There are
of them,
rogue
but
black
most of them are
holes
small.
wandering. There are rogue black holes wandering in our galaxy.
Well, I know that, and rogue planets. But then there's what, intergalactic space? Well,
Yeah.
whatever. This is
Well,
fascinating.
it's just fewer and farther between, but they're still there.
And this is something you guys can't focus on, this porphyrion.
Oh, this is a radio wave image.
Oh,
Let's see if
fascinating.
I can find this is
LOFAR.
LOFAR, low frequency array, located primarily in the Netherlands.
Host galaxy. And then it obviously shoots out of the sides of the galaxies, way beyond the
It shoots
galaxy.
out of it depends how the black hole is oriented with respect to the galaxy, but I assume that the poles of the black hole are aligned with the north and south pole of the galaxy, so they don't have to go through much near gas. They have quick access to cosmic space out there.
Wonder what that concept is called. It's not Coriolis, that's something else.
No, there's a name for the effect, or how these things create this structure, and it is called Kevin Helmholtz instability.
Wow. Well, here's a little
It's how you see a denser jet material at high speed alongside a sparser, slower gas outside. It creates wave-like billows.
And this is really emphasizing the billows, especially around that end.
Yeah. It's the same effect that creates clouds, and you see it in clouds and oceans on Earth. You see it in Saturn's bands, and you see it in the solar corona.
Wow.
This is an artist concept of what we're looking at. This is the cosmic web, the stuff that looks like neurons all coupled together. These are clusters of galaxies at the nodes. And here is this galaxy, and it's relatively free of the surrounding stuff, so it can shoot this quantum material straight out into empty or sparsely populated universe. And you get it when it runs into stuff, it finally slows down and dumps its energy. Then you see these bright nodes at the end.
Well,
So
would our local galaxies, we were just talking about Triangulum and Andromeda and us, be inside one of those parts we're looking at?
If this were our galaxy, we would be right there inside the galaxy somewhere, about halfway between the center and the edge of the bright spot.
And we're kind of on the edge of a void, so we would be along the periphery of one of these filaments, Ron.
One of these filaments, yeah.
Yeah.
Oh, okay. The void inside our Milky Way.
No. This would be a galaxy here. So that would be the Milky Way. And this is a void in the cosmic background.
Oh, okay. Got it.
Now these are quantum fluctuations from the uncertainty principle of when the universe was really small and it blew up so fast, these cosmic or quantum fluctuations were frozen in. And so there are laws that govern these things, how they are. And so far they follow the laws of quantum fluctuations expanded. And that's why they want to have the Big Bang Theory has such a sudden explosion or not explosion, but expansion at the very beginning.
Yeah, rapid inflation.
Yeah, you somehow have to move fast enough to capture all this structure. Otherwise, it would try and equalize out with heat flows and stuff.
Right. You have to expand faster than the speed of light to escape causality and get lumpiness.
Faster than the speed of light?
Yeah, space can expand faster than the speed of light.
and does.
when it's large enough. I mean,
No.
No, especially
No.
when it started. It was really,
Oh,
really,
In like the first 10 to the minus 30 something seconds.
but just like our galaxies, including us in the local group, which are coming together, Andromeda is heading our way, are all these little galaxies we're seeing in those strands at the one time that everything is trying to expand away and dark matter, dark energy is pushing out, they're trying to collapse together, aren't they? Make even thicker strands?
they may
Grab-
be, they may be close enough for gravity to get them, but they're also expanding.
Wow.
Chuck, you were going to say something?
I was just going to say, if they're gravitationally bound strongly enough, they don't participate in the expansion.
Yeah,
Okay.
that's distance dependent. And this again is an artist's rendition. And we may see things like this in future science fiction movies.
That could come from a science fiction novel right there.
Okay, this is, I got confused over the weekend. Apparently there's two Chang'es. There's 5 and 6. And 6 is on the moon now or on roving on the backside. This is Chang'e 5, which landed a while ago, picked up some lunar soil from the backside, I believe. And
Yeah.
here it is taking off to bring the samples back to Earth. Now, among the samples are glass beads. And the glass beads can be created both by impact, because there's a lot of energy released. Everything becomes liquid at some point in the center there, depending on how big it is, or also by volcanism. And the Chinese scientists have developed techniques of isolating spheres that could be volcanic in origin, and then looking at the isotope ratios in them to decide how they formed. Are they shock formed or are they heat formed? And they have apparently narrowed it down to like 3 glass beads that are definitely thermally formed. So the conclusion is that they have volcanism on the moon, but the volcanism now, according to these results, happened within the last 165 million years, which geologically is like yesterday. So that's the news from this article, is that volcanism is recent. Now, in doing that, we have a lot of soil samples from Apollo. And now that China has developed this technique, we're going through and digging through the thing and finding glass beads. And we're starting to apply the Chinese technique to them. And so there'll be upcoming, there will be new information on this.
But glass is silicon, isn't it?
Yeah, it's silicon oxide.
And it's normally not found like that in nature unless something hits it or burns it or explodes, and it's the only way we get it, huh?
Right. And it can be made of other things besides silicon, but
Are they transparent or translucent? Can you see through them?
it depends on the composition. Glass is just like a term for sort of this polymorphic crystal type conglomeration, almost like a frozen liquid.
Well, do you suppose there's still magma underneath in the moon that never comes out?
There is, yes.
Yeah.
There is. Wow.
And it may come out these days. I mean, the seas on the moon are magma that came out on a massive scale from some humongous asteroid hit. And the part that starts now was at one point liquid, and then it cooled to give a roughly smooth surface.
Well, Mr. President, I hate to move you along, but that secondary moon that's coming in is going to orbit. What if it were to crash? Would it make us some glass beads?
Not even close.
The temporary, mini moon.
Yeah.
Look at this. My daughter sent me this and wondered what it was all about. And I said, I don't know. I hadn't heard about it.
Well, here's the Earth.
Yeah.
And this is not the moon. This is the moon's orbit. And there's the moon right there. And this is this thing coming in, 224 PT5. comes in like this. It swings by the Earth, and it goes through this almost a complete orbit, and then it goes back here, and it just keeps on going. So this is between September 29 of this year to November 25. For that 3 months, it will be a secondary moon of the Earth, but it'll have too much energy to stay around.
Okay, what's the size of this sucker?
30 feet, roughly.
And how long have they been tracking it? Did they just discover it in the last?
Well, look at the name, 2024 PT5.
Okay, what does that tell me?
It was found in 2024. And first you get 2024 A, B, C, D, and then you go to AA, AB, AC. And this one got all the way up to PT 5 times. So we're finding so much stuff.
Well, what
It
if
was a recent discovery.
Yeah.
so if it was on a beeline right for the Earth, we wouldn't have had time to do anything, would we?
Not much.
No,
Hmm.
But 30 feet would just
that'd
make
be
a,
like Chelyabinsk.
Yeah.
yeah, okay, got you right. Russia. Fascinating. One orbit around Earth or Moon or both
Both.
Yeah,
together.
around our
Okay.
center of gravity. One
Wow.
quick view. This is a photograph taken from Australia of comet Tsushinshan
Atlas.
Atlas. That's right. Thank you. So taken from Australia.
And
Wait
they're
a minute.
thinking it might be visible in the daytime coming up around
Uh-huh.
October, starting in the second week of October.
Southern Hemisphere only.
No.
No,
Mhm.
here too.
Oh wow!
This was
Wow,
taken on
wow.
September 20.
Right. It might
What is that?
be near Venus, you know.
And what is Atlas?
Atlas is a survey system.
Yeah, yeah.
Okay, so
It was
everybody,
taken by a C11 telescope with a Canon 6D DSLR at ISO 1600, 5 12-second exposures stacked.
Mm.
Field of view is 2 by 1 degrees. So the full moon would fit right like this.
Oh, it's gonna be big.
Yeah.
Mhm.
well,
And
you
for the
put
exposure time, it's not that faint.
you put 2 dates in your talking points, Mr. Perez. Sun, September 27th, Earth, October 12th. What does that mean?
That's when the object is nearest the sun on that date, and the other one is when it's nearest the Earth.
Oh, okay, so October 12th we'll get a better view.
Yeah.
So it's coming around, swinging around the sun, that it's going to be on its outward journey
Yes.
when we see it. Fascinating. I wish we had more time because I enjoy this course in photo astronomy. And someday, Tim Crawford, maybe we'll have a on-stage review of photography with astrophotography. Gentlemen, that'll do it for number 187. I guess we ran out of time, but pretty much everything worked. I don't know how we pull this off. I'd like to say adios, adieu, and Chuck McPartland Hasta Nebula till next week when we'll do number 188. And then on Friday the 4th, we're going to learn about dark matter. Everybody, come join us.
Tom will we'll get together at Westmont again.
We'll talk
Yeah,
next
next week.
next
Bye.
Monday morning. All right, guys. Thank you very much. SBA